Hello, everybody, and welcome back here at the Lab Innovation stage. Please welcome our next speaker, Dr. Ralf Wörl. It's all about safety cabinets of the future, flexible and digital. The floor is yours.
Thank you very much. Hello. My name is Dr. Ralf Wörl. I'm from Berner International. We are a mid-size company with 150 employees. We are located in Germany, in the north, a little north of Hamburg, in Elmshorn. And to give you a short company profile, our main focus in development is on safety cabinets, what we talk about today. And beside that, we also develop sealing systems for dangerous or toxic hazardous lab waste. And beside this field of business, we are also providing personal protective equipment and disposables, mainly in the field of pharmaceutical applications, for example, when handling CMR trucks for chemotherapy. And you will get also some lab interior things from Berner. We offer service for our instruments all over in Germany and with our partners also in the most European countries. And we also have the Lab Excellence Academy where we teach the safe handling in the field of dealing with chemotherapy drugs. We also have a lab facility where we can test all these devices because it's very important to have safety cabinets tested to their protection function. That's the most important issue when you use such devices. This is an overview over our product family. The main focus is on safety cabinets of Class 2. The Claire Neo is something that we show here at the Achema. That's the newest generation of safety cabinets. Beside that, we have also some models for special needs. For example, large-scale safety cabinets for applications where you use large equipment and several other versions where you have, for example, with the Claire LH, an integrated liquid handling station, which is fully tested to full protection with this integrated device. To give you just a brief overview over the history of safety cabinets and what the development goals at different times were, the basic idea actually came with the beginning of microbiology. Scientists like Robert Koch, for example, they developed first ventilated devices to protect in their research the workers, the scientists, when working, for example, with tuberculosis. So the pathogens at that time, you could see in this work that some of those pathogens are airborne and by that infecting scientists who did research on such microorganisms. In the development of between 1940 and 2000, that were the technical basics that were developed for safety cabinets, the filter technology using HEPA filters, for example, the construction principle, or also the airflow and van technology. Around 1970, first standard requirements for such technology came up, mostly in the United States at that time. And nowadays, this is a highly controlled technology with different needs for testing. In 2000, from 2000, actually, the main focus in development was on ergonomics, like also including sound pressure levels and energy efficiency, for example. This is the basic design principle of a safety cabinet. Here is shown a 3-filter system, and you have the main filter level under the workplane in this construction. You see the contaminated airflow patterns in red, the inflow from the lab environment, particles that are set free during the applications inside the workspace. And you see also how the downflow filter, the laminar airflow, is created in this cross-section by the recirculation filter on top of the workspace. The protection goals for safety cabinets are can be divided in three main functions. The first is, and most important probably, is the personal protection. This is the protection against dangerous infectants or chemicals, for example, CMR drugs, which are toxic to the people who work with that. And this is an exposition that comes from inside the safety cabinet. But yes, there's also the goal to protect your products in cell culture experiments, for example, or in sensitive assay formats. And this is a protection against exposure from contaminants from the outside of the safety cabinet. The cross-contamination protection is very important also in many automated processes, in liquid handlings, for example, that you don't want to contaminate your assays from contaminants that can be generated in pipetting, for example. These are the most important types, class 2 safety cabinets. Shown are 2-filter and 3-filter systems, and they differentiate in the total space inside the safety cabinet, which can be contaminated. And the 3-filter system offers a 2-fold HEPA filter, so it's much more efficient in protecting environment and personnel. What are the requirements of today for a safety cabinet? That's changing over time, of course. And nowadays, the development goals are, for example, the optimal integration into the laboratory. There's also a demand for flexibility in all applications. And this is something that such a device should fulfill nowadays. And in another important topic of today, shown here in the former presentations, is of course digitalization. And their sensor technology and connectivity can be an important goal to achieve also in such a protecting technology. Other goals besides that are high energy efficiency, sustainability, and it's also very important to meet customers' needs in offering customized solutions. So this is the main goal of being flexible for all kind of applications that you have. And overall, of course, the protection for such a technology is always the highest priority. So you have to keep in mind that such a device need also to be intensively tested to fulfill these protection goals. Our development ClearNeo goes completely strictly in this direction. So it's designed for this new flexibility and for digitalization as well. One new feature of this technology are novel outer dimensions for best planning in laboratory environments. It has an exact metric dimension, external dimension. So the outer, the width is at exactly 120 or 150, 180 centimeters, and the depth is exactly 80 centimeters. And with these dimensions, this is optimal for lab planning. So it fits completely in the way how modern labs are constructed in the whole architecture. Another new part or a new feature of the ClearNeo is the maximum flexibility, and that's consequently achieved by being able to retrofit the system at a later point. So, for example, you can decide 2 years later to have the integration of a monitor in the rear wall of that safety cabinet if you develop in a direction, an application where more digitalization, for example, is needed. And you have different types of worktops that you can interchange between every ClearNeo model. You have the possibility to integrate functionalized worktops. You can also, what we shown before, switch from a 2-filter system to a 3-filter system by just changing the base stand of that safety cabinet. So this is something also very new that you can use to adapt to upcoming demands and requirements in your work. Here are the worktop design shown. For example, the typical standard is stainless steel in this case, and in this the typical material used in these applications. But with the design of these worktops, it's really easy to interchange the work plates. You have only 2 sizes, and you have 2 smaller side elements, and every other element is also made in a 30-centimeter grid, so that you can easily exchange plates from different material, or also with functionalized worktops as shown here. Here are some examples: a magnetic stirrer, a tempering field, a backlight for cell culture and visualizing, or an integrated keyboard in the worktops. And these functions are simply in plug and play, in inserting into the safety cabinet. With that, you have the power connection, and also for the keyboard, for example, the data transfer. And the whole concept gives you simply more space for your work inside the safety cabinet, and it's also a clean and very hygienic and, of course, flexible concept. New is also the user interface for the safety cabinet. It gives you much more functions. It's intuitive in its use, has a drag and drop function. It's possible to run videos on that monitor. You have different ways of logging in to this technology. You can log in via a code, or also via RFID chip. And there are also all kinds of customer-specific functions possible. And that gives you, from the user interface, user-friendliness, efficient and safe use, and also, again, the adaptation or the possibility to adapt to future requirements. The important feature is digitalization and data transfer. And this is important now, as we have seen also in the other presentations, to integrate such a device in a modern lab environment. Our safety cabinets have an already implemented OPC-UA interface, and with that you can monitor different features of the safety cabinet, the status, airflow, user logins, alarms, temperature, and all that. And it's also a preparation for remote diagnosis, and you can also connect to in different ways to other instruments, as we have that also shown in our work case here at the Smart Lab Solutions booth. So you can also make your safety cabinet to an IT workplace. You can always at any time integrate a monitor in the rear wall. You can use the integrated keyboard for data input, and you have also the connection, or can easily connect to a PC or a local network. So this is at all time of the lifetime of such an instrument possible. And very important for the hygienic concept, all these features are very well cleanable, so you have the necessary hygienic design as well. Sustainability is also a theme of today. So these safety cabinets are highly energy efficient by choosing energy-saving components, also achieved by intelligent van control. and the optimized airflows inside the safety cabinet. You have dimmable LED light to save energy. You have auto on-off functions as a possibility. And you can also switch between different settings in the air streams. And you have also a special energy saving mode to optimize your energy needs. So this is green tech and also a contribution to carbon dioxide reduction. With the flexibility of retrofitting the safety cabinet, you have also a tool to save resources. So in former times, it would have not been possible really to integrate a monitor afterwards. Therefore, if you would have that need, it would require a new safety cabinet. You can also, with these safety cabinets, switch from a 2-filter system to a higher protecting 3-filter system afterwards. Before that, you would have also need a complete new machine, new device, and now you can, at relative low costs and with relative low material needs, achieve this switch. And this is something that contributes to sustainability as well. Other features are listed here, like the regional suppliers that we use for the manufacturing. Most parts have a very high lifetime of 15 years or more, except the filters, for example. They are, as they are contaminated at a certain time, and of course interchangeable, but all other components are of very high quality, and that contributes to sustainability by this longevity, actually. Also, the materials that you use in the safety cabinet are recyclable. Most, there's at least 90% possibility to recycle such materials. Yeah, in the development of Clear Neo, of course, we haven't changed things that were achieved also in the former generations. So you have this intense testing in our labs. You have the same design idea in this system that we followed. We have also all the ergonomical and technical features from the first generation that were valuable, and that's what we continued in this development as well. So, and we are really proud to tell that this concept recently won the Red Dot Design Award. That's a European design prize, what is probably the most important in Europe. And so that's the first part of my presentation, showing the features of the flexible and more digital Clear Neo generation. But what we also offer for our customers are customized solutions. So here are shown the possibility to, very briefly, how you can adapt a safety cabinet to special needs. And we are all working in the lab with large devices. Very often this will not fit into a safety cabinet. If you need the protection for certain experiments and your workers in the lab, then you cannot use a standard safety cabinet. So for that, upscaling is one option. And another option is to modify the workspace for a certain application. You can also combine a safety cabinet with other often used and necessary safety devices or instruments. And you can also integrate machines for certain applications into the workspace of a safety cabinet. And the highest art is really an individual containment that you need for a very, very special application. That's also something that we can offer. This is an example for integration. This is a small pharmaceutical capping and filling machine from Colana, and that is that was used in a setting where you need a very high protection level for personnel and also for cross-contamination. So safety cabinets will be the device of choice for these protection goals. But this machine weighs over 100 kilograms, so that's nothing that you can just place on the worktops. So integration was in this case the way to go. And this machine now sits on a special rail system so that it's accessible for cleaning and for maintenance as well. And so, of course, again, this machine in this integrated way was also tested to all these protection goals in our labs. This is another special Kiro for sample preparation machine for hazardous samples, biological material. So personal protection again was the first requirement. And this very tall equipment, again, wouldn't fit also in a large safety cabinet due to its height. And for that, an adaptation was chosen to really excel the height of the workspace as much as possible, also by lowering the work level or the worktop level. And again, in-house testing for the proof safety features was achieved, and that's how we could offer the customers a safe environment for these experiments. This is an example where a freeze dryer is combined with a safety cabinet, also in a full stainless steel design to be used in a pharmaceutical setting. And again, hygienic measurement and safety in handling these samples from the freeze dryer was needed. And in here you see a door in the side wall of the safety cabinet as the entry to the freeze dryer. So this is an example, again, how to combine with another instrument. There are many possibilities for us to fulfill different needs in that. And that's something you can talk about with us. This is also just, again, an example how you can adapt your safety cabinet to an IT workstation with monitors, shelves aside, also computer. And this is, again, one solution that we have realized in the past years. Yeah, so I think now we have little time for further questions, and other than that, I'm at the end of my presentation. Thank you very much.
So thank you, Mr. Wörl, for this interesting talk. So do we have questions from the audience or some comments or anything?
I have a question regarding the monitor that you showed inside. Is that just a monitor, or is there a computer integrated?
This monitor typically is just a monitor, but it can be combined with every computer that you have in mind. So it can be a small PC on the rooftop, like shown here at the booth, at our booth, or it can be any PC that you have in the lab aside of the safety cabinet or a local network, whatever. So the connection is let out typically to the roof, but can be designed to your needs especially. So, and we can offer all kind of interfaces that you need for that.
Okay, and it was 21.5 inches, I think. Do you also offer larger monitors, like 27 inch?
Depends on the monitor. 27 could, in a standard size, already be a little bit difficult. But for example, in the Claire XL version, this is doable, of course. I think for the standard cabinet, 24 inches was so far the largest that fits in. So there are some limitations by the size of the rear wall. So, yeah.
Okay, thank you.
Yeah.
Additional questions? Okay, then thank you, Mr. Wörl.
Thank you very much.
We make a 5-minute short
Bye-bye.
break.